In the previous video, we learned that alkanes are a homologous series of hydrocarbons composed entirely of carbon and hydrogen atoms. These molecules contain only single covalent bonds and no double bonds, which makes them saturated compounds. We also covered the names and molecular formulas of the first 4 alkanes in the series: methane, ethane, propane, and butane. In this video, we're going to discuss the physical properties of alkanes and understand how to write balanced chemical equations for their combustion reactions. Although all alkanes share similar characteristics, there are important trends in their properties that you need to understand, especially how they change as the carbon chain length increases. The first trend to note is that boiling point increases with chain length. This means that alkanes with shorter chains, such as methane, ethane, propane, and butane, have low boiling points and therefore exist as gases at room temperature. However, as the carbon chain becomes longer, the boiling point increases significantly. As a result, longer chain alkanes are liquids at room temperature, and if the chain is long enough, the compound may even exist as a solid. This increase in boiling point also influences another property, volatility. Short-chain alkanes are more volatile, which means they evaporate more easily due to their low boiling points. In contrast, long-chain alkanes are less volatile and tend to be more viscous, which means they are thicker and stickier in texture, similar to the consistency of honey. Another trend is flammability. Shorter alkanes ignite more easily and are therefore more flammable than longer ones. This makes the smaller alkanes especially useful as fuels, as they burn readily and cleanly in oxygen to release energy. Now, let's talk about combustion reactions, which are some of the most common and important reactions involving alkanes. One of the main uses of hydrocarbons such as alkanes is as fuels, because they release large amounts of energy when burned in oxygen. When there is plenty of oxygen available, the alkane undergoes what we call complete combustion. In this type of reaction, the hydrocarbon reacts fully with oxygen to produce 2 products, carbon dioxide and water, along with the release of heat energy, making it an exothermic reaction. From a chemical perspective, during combustion, both the carbon and hydrogen atoms in the hydrocarbon are oxidized, meaning they combine with oxygen. Carbon forms carbon dioxide, CO2, and hydrogen forms water, H2O. You will often be required to write and balance chemical equations for these combustion reactions. Let's walk through 2 examples. Example 1. The complete combustion of propane. We already know that propane has the molecular formula C3H8. We start by writing the unbalanced equation, C3H8 plus O2, CO2 plus H2O. Now we balance the number of atoms. There are 3 carbon atoms in propane, so we need 3 CO2 molecules. Propane has 8 hydrogen atoms, and each water molecule contains 2 hydrogens, so we'll need 4 H2O molecules. Next, we count the oxygen atoms on the right-hand side. We have 3 CO2s, which give us 6 oxygen atoms and 4 water molecules, which provide for more oxygens, making a total of 10 oxygen atoms. To get 10 oxygen atoms from O2 molecules, we need 5 O2s. The final balanced equation is C3H8 plus 5O2, 3CO2 plus 4H2O. Example 2. The complete combustion of nonane, which has the formula C9H2. We begin again by writing the unbalanced equation, C9H2 plus O2, CO2 plus H2O. Since there are 9 carbon atoms, we will need 9 CO2 molecules. With 20 hydrogen atoms, we will need 10 H2O molecules. On the product side, we now have 9 CO2s, which give 18 oxygen atoms, and 10 H2Os, giving 10 oxygen atoms, so 28 oxygen atoms in total. That means we need 14 O2 molecules on the left-hand side. The balanced equation becomes C9H2 plus 14O2, 9CO2 plus 10H2O. Let's summarize the key points from this lesson. The physical properties of alkanes, such as boiling point, volatility, viscosity, and flammability, depend on the length of the carbon chain. Shorter alkanes have lower boiling points, are more volatile, more flammable, and make excellent fuels. When burned in the presence of sufficient oxygen, they undergo complete combustion, producing carbon dioxide and water and releasing large amounts of energy. This type of reaction is exothermic and very useful in everyday life, from heating homes to powering vehicles. That's all for this video. If you found it useful, feel free to share it, and we'll see you again next time for more on hydrocarbons.